Welcome to Wednesday, March 25th, 2020 notes. We're talking about 6.5 special parallelograms. Yesterday we talked about rectangles. Today we're going to discuss rhombi and squares. So our definition that I'm going to give you is about a rhombus. And a rhombus is a parallelogram with four congruent sides. So drawing a picture, if I had to take a look at what a rhombus would look like, doing the best that I can, I've got a parallelogram with four congruent sides. So remember, opposite sides have to be parallel. So here I'm putting in the parallel markings. So I got my two arrowheads here, and now I've got my single arrowhead here. So a rhombus is a parallelogram with four congruent sides. So by definition, we know that a rhombus is a parallelogram, which means it has all the properties of that parallelogram, much like a rectangle that we studied yesterday. So a rhombus has opposite sides congruent. Sorry, here with my notes, congruent. A rhombus has opposite sides parallel. A rhombus has opposite angles congruent. A rhombus has diagonals that bisect each other. And a rhombus has consecutive angles that are supplementary. So a rhombus has all of the properties of a parallelogram. In addition to those properties, we're going to study two more today, and that is theorem 6.15, which says that if a parallelogram is a rhombus, then the diagonals are perpendicular. So taking a look at this rhombus ABCD, I know it's a rhombus, then the diagonals will intersect at a right angle. So this angle is a right angle, which means all the other angles in the middle where the diagonals intersect will also be right triangles or right angles. So I have four right triangles as well. If a parallelogram is a rhombus, then the diagonals bisect a pair of opposite angles. So here this diagonal RP cuts angle NRO in half, NRQ in half, and it also cuts angle NPQ in half. This diagonal NQ will cut angle RNP in half, and it will also cut angle RQP in half. So what you see is that these diagonals will make these angles congruent. Also know that these angles right here, those angles will be congruent because they are cut in half. They're bisected. So those are the two theorems we're going to look at. So I'd like to get started with some examples. All right, example number 1 here. It says the diagonals of a rhombus WXYZ intersect at V. If the measure of angle WZX is 39.5 degrees, find the measure of angle ZYX. So I'm just going to go on and write in this angle measure. So WZX is 39.5 degrees. Well, if that angle is 39.5 degrees, I know that angle YZV is also 39.5 degrees. I also know that angle WXV is 39.5. And finally, YXZ is 39.5. All right. So if I wanted to, I think I have enough information to go on and solve. And I know that these angles are congruent because this diagonal XZ right here bisects both those angles. Any angle along XZ here, they're 39.5. All right, so I'm just going to go on and go from here. I'm going to highlight the following triangle in red. So if I look right here, I know I have all that I need to solve. I've got a rhombus, so I know that these sides are congruent. I've got my base angles that are congruent. So I know that triangle XZY has to add up to 180. So 39.5 plus 39.5 plus the measure of angle ZYX has to equal 180. So 39.5 plus 39.5, when I take and add those two together, we get 79 degrees. So 79 plus the measure of angle ZYX, that's 180. I'm going to go on and subtract the 79 from both sides, and I get that the measure of angle ZYX is 101 degrees. And I'm finished. Example number 2. If the diagonals of a rhombus intersect at V, if WX is 8x minus 5, and WZ is 6x plus 3, find x. Well, again, the key to this problem is that they tell me I have a rhombus. So since it's a rhombus, I know all the sides are congruent by definition. So that means that WX is equal to WZ. So segment WX is congruent to segment WZ, therefore their lengths are the same. So 8x minus 5 equals 6x plus 3. We've solved many of these throughout the year. I'm going to add 5 to both sides. 8x is equal to 6x plus 8. We're going to subtract the 6x from both sides. We get that 2x is equal to 8, and that means x is equal to 4. And we are done with example number 2. Okay, example number 3, I'm told that ABCD is a rhombus, so I'm going to go on and put my markings to let me know it's a rhombus. It says find the measure of angle CDB. So they want me to know what is the measure of angle C to D to B. They want this angle right here. So that's the angle that they want me to find. If I know that angle ABC is 126. So what I know is that the distance from here to here is 126 degrees. Well, this segment BD right here will cut 126 in half. So 126 divided by 2, that's where I'm going to bisect it, is 63 degrees. So this angle is 63 degrees. That means this angle right here is 63 degrees, which means the angle that I'm looking for, the angle CDB, is 63 degrees. And I also know that ADB is 63. I'm just going to fill it in. I know that CDB is 63 degrees, and I go on and move on. Example number 4 says ABCD is a rhombus. BC is 4x minus 5. I know that CD is 2x plus 7. Because this is a rhombus, I'm marking all the sides being congruent. So much like the example number 2, BC equals CD. 4x minus 5 equals 2x plus 7. I'm going to subtract the 2x. I get 2x minus 5 equals 7. I'm going to add the 5. I get the 2x equals 12. That means x equals 6. And I'm finished. So here I'm going to make my hierarchy chart in terms of quadrilaterals today. So we're going to start off with what is the very first thing we discussed, and we talked about all quadrilaterals. And specifically the past couple of days we've been focusing on quadrilaterals that have 2 pair of parallel sides. And that's what we called a parallelogram. And after we studied the parallelogram, what did we look at yesterday? We looked at rectangles. They are a specific type of parallelogram. And then from the rectangle or parallelogram, today we just discussed a rhombi. So a rhombus. And a property that has, or a shape that has both properties of rectangles and rhombus is what we call a square. So here is my hierarchy chart, and it allows me to make decisions. So I could say, I could work my way up the hierarchy chart. I cannot work my way down the hierarchy chart. Meaning that all squares are rectangles. All squares are rhombus. But not all rectangles are squares. Some rectangles are squares, but not all rectangles are squares. So I could say all rectangles are parallelograms. All rectangles are quadrilaterals. All rhombus are parallelograms. All rhombus are quadrilaterals. So you could work your way up, you cannot work your way down. So now we're going to learn about conditions for rhombi and squares. So what makes a quadrilateral a rhombus? What makes a quadrilateral a square? So theorem 6.17 says that if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So if I know that something is a parallelogram and the diagonals intersect at right angles, I will no longer call it parallelogram, but more specifically, it will be a rhombus. Theorem 6.18 says if a diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So if I know my shape is a parallelogram, and I see that I have a diagonal drawn in, such that the angles are split in half, or all the angles along this diagonal are congruent, then it is a rhombus. And lastly, for rhombus, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So as long as I see something like this, where I have a parallelogram, and I see that these consecutive sides are congruent, then that means that it is no longer a parallelogram. This guy is a rhombus. And lastly, if it is going to be a square, it has to have a property of both a rectangle and a rhombus. So here's our example. It says, is there enough information given to prove that ABCD is a rhombus? I know that ABCD is a parallelogram, so we put in our chunky arrowheads. We know it's a parallelogram, and then they're telling us that segment AD is congruent to segment DC. So ABCD is indeed a rhombus. And that's why right here, because ABCD is a parallelogram with consecutive sides congruent. So I had a pair of consecutive sides that are congruent, therefore I know that this guy is now a rhombus. Hector is measuring the boundary of a new garden. He wants the garden to be a square. He has set each of the corner stakes 6 feet apart. What does Hector need to know to make sure the garden is a square? Well, since opposite sides are congruent, so I have opposite sides being congruent. This is a parallelogram. Okay, and then I have a pair of consecutive sides are congruent. So this is a rhombus. To prove a square, we need to know if the diagonals are congruent. That's what Hector needs in order to show that this is a square. So in order to prove the square, we need to know the diagonals are congruent. Because in order for it to be a square, it has to have both properties of a rhombus and a rectangle. So the last example here that we have is, can you conclude the parallelogram is a rhombus, rectangle, or square? So I was told that these are parallelograms. So here I have a diagonal that bisects opposite angles. So this is a rhombus. Here I have a quadrilateral that's stop. More importantly, this is a parallelogram, stop. I know that SO is congruent to TP, so this means this is a rectangle. The third example, I see that the diagonals intersect to form a right angle. So since they intersect to form a right angle, I know that that's going to be a property of a rhombus. But then I look and I see that the diagonals are bisecting each other and they all have the same tick mark, so that means the diagonals are congruent and they intersect at a right angle, so this is a square. And our last example, I see that the diagonals here intersect at a right angle, and I know that's a property of a rhombus. I thank you guys today. That's section 6.5. So I hope that you guys could find the homework tonight on Schoology and attempt them and carry on with success. Have a great day, men.